A t-test is a statistical method used to compare the means of two groups or samples to determine if there is a statistically significant difference between them. It is particularly useful when working with small sample sizes where the population standard deviation is unknown. Based on the t-distribution, the t-test helps assess whether the difference in means could have occurred by random chance or if it is statistically significant. There are three main types of t-tests, each suited to different situations. First, the independent samples t-test, also known as the two-sample t-test, is used when comparing the means of two independent groups. For example, suppose you want to test whether there is a significant difference in average test scores between two groups of students, Group A receiving traditional classroom teaching and Group B receiving online teaching. By applying the independent t-test, you can assess whether the difference in average scores is statistically significant. Second, the paired samples t-test, also known as the dependent t-test, is used when comparing the means of two related groups. These could be before and after measurements on the same individuals. For example, imagine you are studying the effect of a fitness program on weight loss. You measure the weight of 20 participants before and after the program and use the paired t-test to determine if the weight loss is statistically significant. Third, the one-sample t-test is used when comparing the mean of a single sample to a known population mean, or a hypothesized value. Let's say a teacher believes the average IQ of her students is higher than the national average of 100. She tests 30 students and finds the class average is 105. The one-sample t-test will help determine whether this observed difference is significant compared to the population mean. Now, let's break down the steps involved in conducting these t-tests. First, you set up hypotheses. For example, in the independent t-test, the null hypothesis states that the means of the two groups are equal, while the alternative hypothesis states that they are not. You then calculate the t-statistic using the formula that depends on the type of t-test you're performing. After calculating the t-statistic, you compare it to the critical value from the t-distribution table, which tells you if the result is statistically significant. In terms of applications, t-tests are widely used across fields. In medicine, t-tests compare treatment and control groups in clinical trials to determine the effectiveness of new drugs. In education, they help compare different teaching methods by analyzing test scores. In business, t-tests are used to compare marketing strategies by analyzing sales data. In psychology, they assess the impact of interventions, and in quality control, they test whether a manufactured product meets industry standards. To summarize, there are three main types of t-tests. 1. Independent samples t-test, for comparing two independent groups. 2. Paired samples t-test, for comparing related groups, such as before and after measurements. 3. One-sample t-test, for comparing a sample mean to a known population mean. Each test plays a crucial role in evaluating data, helping researchers and professionals make informed decisions based on statistical evidence.